Yeah, we'll try it. We'll just kind of see how it goes. But yeah, it might pick up your voice. So this is 6-4. And we're going to talk about proportional and non-proportional relationships. So let's first talk about what proportional means. So do you remember, well actually later in the chapter we're going to learn how to solve something called a proportion. But a proportion is when you have, if something is proportional to something else, it's relating to rates and saying that they're equivalent and that they have a constant ratio or rate. So let's write that down first and then I'll give you an example of what I mean by that. So proportional means that they have a constant rate, or we could also say ratio. Now that word constant, what does that mean? Ashna?
Like it doesn't change.
Right, it doesn't change. It stays the same. So like we've talked about a constant, it would be a number. Like the number 6 is constant because it's always equal to 6. So if two ratios are equivalent, they have the exact same ratio. An example might be if you have 2/3, and then that's a ratio comparing two things, and then we relate it to 4/6. Are those, do they simplify down to the same rate or ratio? Yes, they're equivalent, so they are considered proportional. If you have, though, what do you think non-proportional would be? Jules?
2/3, 2/3, 1/3.
Okay, well, let's even give it a different,
1/6.
okay, 1/6. Because, so is 2/3 equal to 1/6?
No.
No, they're equal to different ratios, so that would be non-proportional. And we can just abbreviate here, prop and non-prop. Okay, so let's say, let me give you kind of a real world example of where proportional things happen and where non-proportional things happen. Let's say that you are having some friends over this weekend and you're going to order some pizza. And so you have it delivered, and let's say you live kind of a ways away from wherever you're getting your pizza from. And so they charge you a delivery charge. So let's get some notes here. So let's say we're having it delivered. And we're going to say that because you live a ways away, it's a $3 delivery charge. And we'll make a chart here of our information. So we'll say the number of pizzas that we're going to order. We're going to figure out what our cost would be based on how many pizzas we order. So if we say, okay, we'll just get one pizza, that should be enough. I'm only going to have, a couple friends over. One should be fine. And let's say that the cost of the pizzas are $10. So how much would you pay to have that pizza delivered?
15.
You'd actually pay $13. Good, because you have to pay that delivery charge. Well, let's say you hear back from more friends and they say, no, we're coming, you've got a couple more friends coming, so you better order 2 pizzas. So how much would your cost be? Hannah?
23.
Good, 23. Why not 26?
Because it's only a $3 charge. It doesn't double. It just stays the same.
Right, so if you order one pizza, you pay $3. If you order 2 pizzas, you still just pay $3 because it's a one-time fee. No matter how many pizzas, it's really for their time to have to drive out to your house. It's that extra fee. All right, so it's only a $10 increase. You're not doubling the delivery fee. Okay, let's say you hear from more and we need to get 3. Maybe your parents and your siblings decide they want to eat pizza. So, Trey, what would the cost be? 33. So it's just increasing up by 10. All right, now let's look at these ratios or these rates and see if they're proportional. If we have 1 compared to 13, so 1 pizza, $13. What do you think? Is it proportional to 2 pizzas for $23?
No.
Are those equivalent? Are they the same constant ratio? No, they're not equal. So therefore, we would say it's non-proportional. That's an example of non-proportional. And so in your homework, you're actually going to be given some either situations where you make a table, or maybe you're given the table, and then you determine is it proportional or non-proportional. And you can prove it, so you won't have to copy the table. You'll just need to prove it with this work here. Izzy?
And would you just do like the first 2 numbers?
You can really do any set of it, and as soon as you find one that doesn't work, then you can stop. Let's say, though, in a different situation, let's say you decide your dad's going to be on his way home from work, and so he's just going to pick up the pizzas. Okay, so we're going to do carry out. So let's compare that. Now, what's going to be different about carry out? Izzy?
You don't have the $3 charge for the delivery.
Right, you don't have to pay that $3 charge. So I'm kind of running out of room, so I'll squeeze it up here. So here would be our number of pizzas, and then our cost. And so if we get 1 pizza, what's the charge for that pizza? $10. If we buy 2 pizzas, it's going to be 20. 3 pizzas, 30. Okay, so what do you think? If we do carry out, is that proportional or non-proportional?
Proportional.
It's proportional, right? Because if we compare the pizzas to the cost, they're all going to equal and reduce down to a tenth. Or, whoops, I need to change that on the bottom. They all would reduce down to a tenth. So therefore, we can say that these are proportional because they do equal each other. Now, you don't have to write every single ratio down, but you should, if you only write 2, you should kind of look ahead and make sure that later on something doesn't change. But if you know that it's just going to continue same ratio the whole way through, just at least show that you they all go down to, show what they reduce down to. All right, so let's take a look at, let's try to write an equation for these. And we've done some with equations already. Let's say, which one would be our input and which would be our output? Helen?
The input would be the number of pizza and the output would be the cost.
Right, because you're putting in the number of pizzas, that's your input, and that tells you what your cost is going to be. So I'm going to put a little X here and a Y for cost. X for the pizzas, Y for the cost. Could we write an equation for both of these situations? Yeah, why don't you write down, see what you think would be a good equation for both of them. And remember with our equations, we want to put Y equals, and then we'll tell what the, what do we do to the X to get the Y.
Wait for each one.
Let's do, yeah, it'll be 2 different equations because it's 2 different situations. Okay, Jules, which one do you want to give me?
I'll do the delivery.
Okay, delivery
And
is,
Y equals 10x plus 3.
okay. Each pizza is multiplied by 10, and then you add 3 just that one time. All right, Hannah, what about carry out?
Y equals X times 10.
Okay, good. Y equals X times 10 or Y equals 10X. All right, what do you notice? Well, before I get you to make some observations, let's say we have another situation. Let's say, let me give you a couple equations, and let's make these into tables. So haven't we done some of this already before? I forget which class I've shown different things to. But can you fill in the table for these? If I put in 1, 2, and 3 for X. Okay, go ahead and quickly fill in what your results would be if you put in 1, 2, and 3 for X on each of those equations. Go ahead.
answer.
Okay, go ahead. Izzy, you want to do the y equals 3x? What did you get for your y's?
I got 10x, 20x, and 30x.
No, we're doing different equations from the pizza. So it's just a totally separate thing. Were you putting in $10? Okay, I'm sorry. Yes, these are just random equations. They don't have to do with our pizza anymore. Okay? All right, Ashton, what do you think about y equals 3x?
It would be 3, 6, and 9.
Okay, 3, 6, and 9. You just plug in your 1, 2, and 3. All right, Abby, what about the 3x minus 1?
I got 2, 5, 8.
2, 5, and 8, do y'all agree?
Yes.
Okay, now let's just look and see. Underneath here, I want you to prove to me whether they're proportional or non-proportional. So take the information from the tables, follow the example from the pizza, and see if you can tell me if those are proportional or non-proportional relationships. Okay, Cindy, try the first one. What do you think, proportional or non-proportional? Okay, and what's your proof for that?
Because if you simplify 3 9ths, you could get 1/3, so you just have to
Okay, so the last fraction, 3 9ths, reduced down, and does the 2 6 as well?
Yes.
So they all reduce down to this 1/3. That's their constant ratio. So yes, you're right. They're proportional. Okay, what about the second one, Avery?
Non-proportional.
Okay, non-proportional, and can you prove that for me?
1/2 is not equal to this, so it can't be changed, and either can 3/8.
Okay, none of them will go down to the exact same. Now, what if you had 2 of them that went to the same and then a third that didn't?
Non-proportional.
It'd still be non-proportional. It's a counter example. It's finding one time at least where it's not true, and then therefore it's non-proportional. Jules.
I kind of noticed that like whenever it's like a 2-step
Mm-hmm.
equation,
Mhm.
then it's non-proportional because it's almost like you're all multiplying it by the same thing, so you all get something that's divisible by the same thing. Like whatever you multiply the number by, it's going to be divisible by, but if you subtract it, then that messes it up.
Okay, very good. I was hoping actually that you would see that. So, but what she's noticing is with the types of equations, so this one was just being multiplied by 3, and this one was just something being multiplied by 10, and both of those ended up being what? Proportional. But when we subtracted something from that or added, it became non-proportional. So there's actually a form, like in general form in algebra that is for these proportional equations. So Jules, I'll give you a lifesaver point after and for that. That's good. So the general form is y equals kx. And the k just stands for a constant. I don't know why they decided on k, but somebody did. So I'd like you to write that down. That is the form of a proportional relationship, y equals kx. So it's just the x being multiplied by a number, and that will give you a proportional relationship. But if you add or subtract anything from that, it's no longer proportional. Okay, so there's that y equals kx. All right, so let's take some other situations and see if we can write some equations and try to get them in that form, y equals kx, if we think they're proportional. So let's say, haven't really been numbering these things. We'll just, if you want to number yours, that's fine. But if you'll write down that David, he has a little pet sitting business in his neighborhood, and he charges $5 a day to pet sit. Now, in these problems you're going to have in your homework, you're going to be asked to write an equation relating two different things to each other. Okay, so like with the pizza, it was relating the number of pizzas to the cost. Well, in this case, what would be the two things that we might be relating? Patrick? Okay, good. So that's actually how they'll say, like, dollars or cost. So write an equation relating cost to the number of days. Very good. And with these word problems, when it's a real situation, I'd like you to try to use variables other than x and y. Now, we used x and y in the pizza because that was kind of our first one. But let's think about, let's do C for cost. We'll do D for number of days. And I want you to try to write down an equation using C and D. Relate those using that information at the top that he charges $5 a day. So see if you can write an equation. Do you think this will be proportional or non-proportional? Proportional, because it's just every day it's $5 more times 5 every day. Okay, Hannah, what do you think?
C equals 5 times D.
Right. C equals 5 times D. Do you see how that's the y equals kx, but it's just different letters than your x and your y? Something the x, the input is being multiplied by 5. Good. So that's what they're asking for. That's the equation. Now, what if you use your equation then to find the cost for 3 days? Now, you didn't really have to use an equation, but it just is sort of a process that we're learning. So what would you do? Where would you put the 3? What do you think, Clay? Right, 3 is the days, so we'd plug that in right there for D. So we'd say the cost for 3 days is 5 times 3, so he's going to charge $15 for the 3 days. Okay, let's try another one. And this time, well, before I show it to you, what is this called, $5 a day? What do we call that we've learned already in our chapter?
A unit rate?
A unit rate, yes. So we were able to easily just put the unit rate times the days. Well, in this situation, there's a girl in the neighborhood, Nina, and she also has a pet sitting business. But she goes around and advertises that she will charge $34.50, or maybe she doesn't advertise this, but for 6 days for pet sitting. Now let's see how would we find out, first of all, if we wanted to find out who had the better rate? What would you do, Hannah?
You would divide 6 into
Divide 6 into 34.50, and that's going to take that rate down to a unit rate. Exactly. So that's what you should do. If you're not given the unit rate, you should take it to the unit rate first, and that's going to help you write your equation. So let's write that down. Lauren.
Couldn't you just do 6 times the other person's equation? And
If you were comparing, yes. Yeah, if you were comparing, so then we could come over to David and say, okay, what's his charge for 6?
Here, and then
Uh-huh.
I know who she's talking about.
Yes, and I just sort of, sorry, I looked over and Peeves is dancing in the front of her class. Sorry. So, yes, if you were comparing, definitely, I would say go with that route. But let's just say this is its own problem, okay? And it's not really related to David.
Okay.
We also want to be able to change this into an equation. So let's find the unit rate first. So we'll do that like we said, divide by 6. So go ahead and do that if you haven't already. And find out what she charges per day. Okay, Trey, what'd you get?
$5.75.
Good, $5.75. So it's just a division problem there. So that's her charge per day. Now I want you to write an equation relating the number of days to the cost, just like we did before.
Maybe it's like better service.
What'd you say?
Maybe it's like better service.
Maybe she does better. She charges more per day. Yes, maybe there's additional little things she'll do. Maybe she'll bring in the mail for you that David just won't do. Okay, Jules, what's your equation?
C equals 5.75D.
Okay, good. Same kind of, and is that going to be proportional?
Yeah.
Yes. Now, how about this? Can you do something to the problem that would make it non-proportional? Like, think about Nina's situation. What would happen? What could you do to it just to kind of change it up a little bit and make it a non-proportional, Lauren?
Well, you could, I guess, you could add or subtract a number on the end of that equation.
Yes. Anna, can you think of some situation we could add into the story problem?
A $5 like per pet or something.
Oh, yes. Okay, so maybe that would do it as well. So maybe if you have one pet, it's an additional fee of 5. If you had 2 pets, you'd have to pay 10 or something like that. So yeah, an extra fee that's added on. Okay? Izzy?
Maybe if you really liked one type of dog and you had that dog, then she would give you a discount.
Ooh.
Because she liked your dog.
Yeah, so she said if there's a particular breed of dog, or maybe it was just her favorite dog in the neighborhood, so she'd give them a little discount, and that would be subtracted. So then that would be non-proportional at that point. Good. Katie?
I like the size of the dog. 'cause
Yeah,
it's easier
I was
to
gonna
walk,
do
like a
5.
10-pound dog.
Yeah, I was gonna do $5 for like a small dog and $10 for a big dog.
Okay, yeah, so it's talking about fees added on based on the size of the dog. A smaller, maybe if it's a big dog, there's a fee. If it's a small dog, you don't have to pay the fee. So, yeah, good. Excellent. So those would turn it into non-proportional. All right, now what if Nina pet sits for 4 days? How would you figure out what she's going to charge, Ashna?
You would do $5.75 times 4.
Exactly. And we're just going to stop there. I think you guys get the idea. You plug it back into your equation. If she did it for 20 days, you'd plug in your 20 for D and solve. All right, good. Now, let's see if we can stop our video.